All right. Hello, Kaleigh. So we will take a look at the questions that you had on the homework. Homeworks, I should say. All right, and we'll just record here, and I'll just kind of answer the questions. So I'm going to go through each section that you asked for. It's going to be probably a little bit of a long video, but you can of course jump around to whatever you want to see and stuff like that. So I'm starting here on page 501 because I did that lesson first, and then I did the page 491, so we'll just get into that. So in this one, we're doing number 1 first, and then I think we're also going to look at number 5 and number 6. We'll come back to those in a second, but let's take a look at number 1. So number 1 says a person invests $2,560 in an account that earns 5.2% annual interest. Find when the value of the investment reaches $6,000. Okay, so for our purposes, when I taught this to you, okay, we learned that there's a couple formulas for interest. All right, since this one doesn't say anything about how often it's compounded, we're just going to assume that it's compounded once per year. We have this annual interest rate of 5.2%. It's only compounded once per year, so that's going to be our formula. Okay, so we can use the simple compound interest formula, okay, or you can use the compounded n times per year formula, and you'll just put 1 in for n. Okay, so the simple compound interest formula is your final amount is equal to the principal, the initial amount of money, times 1 plus your interest rate as a decimal to the power of t, time in years, right? Okay, and that's what we have here. Okay, 2,560 is our principal. That's our starting amount, so we'll put that in here. R is the interest rate, which is right there, the 5.2%. As a decimal, though, remember that's 0.052 to the t. And then we have our final amount, too. We want to know when this thing is $6,000. So we're going to set this equal to $6,000. Now, at this point, you have two options because you've already gone through the logarithm section of the class 2. So we could solve this using logarithms, or you could just graph the left-hand side, graph the right-hand side, find the points of intersection. Okay, to do that, I'll go to my calculator here. I think it's here and here. Okay, so we'll go to y equals. I'll type in the 6,000. That's what we're shooting for. And then the initial investment was, I gotta take a look here again, 2,560. Okay, 2,560 times 1 plus 0.052 to the, now of course we're not going to use t, we're going to use x here because of, we're graphing and stuff like that. Okay, now, of course with a normal viewing window of, negative 10 to 10, negative 10 to 10, we're not going to see it because if you remember, right, the y value we're looking at graphing here, if I go back to y equals, I'm trying to graph 6,000, right? I don't know when the y value is 6,000, so I need to adjust my window. I'm going to go down to the y max here, which is 10, right? I got to go at least to a y max of 6,000, so I'm going to do like 6,500. And now I'll graph it. Okay, so there's 6,000, and there's our exponential growth, our compound growth, of our investment there. We can see, we need to go further to the right. So again, window. To move further to the right, we're going to adjust the x max. And let's make it, 50, just to kind of, it was 10, let's make it 50. And there it is. So second, whoops, I'll wait for it to finish graphing there. Second, trace, and go down to intersect. Go near that point of intersection and hit enter, enter, and enter one more time. And there's our answer. The x value there you can see is 16.8, y value 6,000. So after about 16.8 years, excuse me, okay, we can expect that initial investment of $2,560 to be up to $6,000 if we can get that 5% annual interest rate. Okay, so there's that. All right. Of course, we could use our, like I said, we could use our logarithms and stuff like that too. So, for example, you could, start with the same equation, divide both sides by the 2,560. Okay, so it'd be 6,000 over 2,560, which simplifies to like 600. Well, I'll just do it this way. Okay, and then we'll have 1.052. If I add these two numbers together, I'll get 1.052 to the t. And at this point, then you can use a logarithm. You can use natural logarithm, you can use log base 10, you can use log base 1.052, whatever you're most comfortable with. I'm going to use the log base 10, just to do that. So remember, when I write just log, that means log base 10. Okay, remember, properties of logarithms, though, when you have an exponent inside your logarithm, we can bring that exponent out front. So I'll bring it out front there. So it's t times that, and so we'll divide both sides by this logarithm right here. So that cancels, and then you can see there's our answer. T is exactly this value. If you type that quantity into your calculator, so let me do that here real quick. Log 6,000, 2560, 1.052. So log 6,000 divided by, I already forgot, 2560. And then further divided by log of 1.052. Oops, missed the 2. And there's your 16.8. Same answer, right? So you can also use logarithms. Okay, at first, when I showed you guys this lesson, you only had to use your calculator to graph it because we didn't know a lot about logarithms yet. But you can also use logarithms here to solve it too. Okay, let me do one more here. I won't do both of these here, but I'll just do one more for you. Let's see here. Yeah, so I mean, both of these are the same. I'll do number 6 because there's space underneath it there. Okay, so Molly invests $8,700, so that's her initial amount, times 1 plus 0. Now, if you look here, we can tell compounded daily. So it's not every year, it's compounded every day. So that 2%, we have to divide it. So the 0.02, we'll divide it by 365, because that's how many times it'll be compounded in a year. And then it's 365 times the number of years, which we don't know that yet, so we'll just put a t there. And we want to know when that equals 12,000. Okay, so you can, at this point, once it's set up, you can type this mess in your calculator, okay? Be careful about how you type it in. You need to type it in very carefully, because otherwise, it won't show up right. Let me see if I can show you that here. So 12,000 and then 8,700. So 0.02 divided by 365. Okay. Whoops, I missed the 0.02. There you go. And that's to the, and then you want to put parentheses around your exponent here, 365x. Like that. Okay. Go to graph. And I already know my graph's not going to be big enough because remember before my maximum y value was 6,000. Now I need my maximum y value to be 12,000. So I have to adjust my window here and I'll make it like 12,500. There's 12,500. There's exponential growth, and we can see the intersection point. So now I can press second trace, go down to intersect, points of intersection there, enter, 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 and there it is. So after about 16.08 years. Kind of an interesting, similar answer to what we had before, but that's kind of just a coincidence. $16.07 Okay, so I'll stop there, and I'll set up for a video for the next. I'll make another video. Actually, I know I was gonna make one big video. I'm just gonna make one video per page there that you gave me. So we'll stop there, and I'll get you set up for the next video.